Dividing polynomials by monomials. So this division with polynomials and monomials is really not much different than just regular division. The only difference here is now we have a little bit of variables, and it really just we're going to use one of the exponent rules. It's going to incorporate one of those exponent rules that we learned back in Unit 1. So let's just get going here. So on A here, we have 20x to the fifth minus 12x to the fourth plus 32x, all divided by 4x. So we're just going to divide them. We're going to divide each of those terms on the numerator divided by 4x. So the 20x to the fifth divided by 4x, we're going to divide those coefficients. 20 divided by 4 is 5. And the x to the fifth divided by the x to the first, this is where you have to remember these exponent rules. So remember, when we divide exponential expressions with the same base, we subtract the exponents. So the 5 minus the 1, this is going to turn into an x to the fourth. So we just divided the coefficients, and then we subtract the exponents because that's the exponent rule. So negative 12 divided by 4 is negative 3. So divide those coefficients for that second term. And x to the fourth divided by x to the first, well, remember we subtract the exponents. 4 minus 1 is 3. So this is going to be negative 3x to the 3. 32 divided by 4 is 8. And then x to the first, right, divided by x to the first is, I guess you can think of this multiple ways, is just x to the 0, which just turns into 1. So you don't even need to write it because 8 times 1 is just 8. They basically cancel each other out. This is it. So on B, we divide the coefficients. So 3 divided by 3 is 1. So I don't even need to write that. X to the third divided by x to the second. Well, 3 minus 2 is 1. So this is just going to be a 1x. 18 divided by 3 is 6. And then x to the fifth divided by x to the second. 5 minus 2 is 3. So x plus 6x to the third is your answer. Now, it doesn't say we have to write it in standard form, so I'm just going to leave it like this. If I was to put it in standard form, I would put the 6x to the third first. Okay. So on C, we divide the coefficients. 10 divided by negative 2 is negative 5. X to the 15th divided by x to the fourth, we subtract the exponents. 15 minus 4 is 11. Negative 6 divided by negative 2 is positive 3. And then x to the fourth divided by x to the fourth, that just, they cancel each other out. They reduce is the better term. They reduce to 1. So we don't need to write that there. They just cancel each other out. Let me do G and I. Okay. So this one's a little bit different just because there might be some fractions with it. So let me show you what I mean. If we have 4x to the 6 divided by 8x to the 1, 4 divided by 8 is like 0.5, right? 4 divided by 8 is 0.5. But I'm just going to simplify that to a half. Okay, you can write 0.5. That would be nothing wrong with that. But I'm going to simplify it to a half. 4 divided by 8 is 0.5, which you convert it to a fraction. This is going to be 1/2 x. Now 6 minus 1 is 5, so this would be x to the fifth. 12 divided by 8, or negative 12 divided by 8, would be negative 1.5. But again, typically we want to leave these as fractions. So if you simplify negative 12/8, that's going to be negative 3/2. And then x to the second divided by x to the first. 2 minus 1 is just 1, so it's just going to be x to the first. I, so we got 4 divided by a half. Now remember, if you're not good with division of fractions, you can just use technology, use a calculator. But 4 divided by a half is 8. X to the ninth divided by x to the third would be x to the sixth. 7 divided by a half is 14. x to the fourth divided by x to the third is x to the first. 12 divided by 1/2 is 24. And x to the third divided by x to the third, those just cancel each other out. So we're left with this. Okay, so you get the idea. You just divide the coefficients, and then the exponent rule says to subtract the exponents. So I'll let you do all the rest for number 1. Now I'm going to go over number 2 with you. So number 2, divide this polynomial by this monomial. So I'm going to do this kind of quick here. 12 divided by 4 is 3. X8 minus X3, X5. X8 divided by X3 would be X5. -4 divided by 4 would just be -1. 5 minus 3 would be 2. And then 8 divided by 4 is 2. And then x to the second divided by x to the third. Well, 2 minus 3 is -1. So this is where it gets a bit interesting. Because it's down here, it says, recall the definition of a polynomial. And this is from the very beginning of the unit. An expression consisting of variables and coefficients that involves only operations of addition, subtraction, multiplication, and non-negative integer exponentiation of variables. The resulting expression at the division is not a polynomial y. So here we have this question up here says, why is it not a polynomial? Explain a full sentence. Well, if you remember, it's based off of this idea. You can't have negative exponents. It is not a polynomial because it has a negative exponent. So that's why it's not a polynomial. And you could also rewrite this as 3x to the 5th minus x squared plus, and since it was an x to the -1, remember we can change this to 2 over x to the +1. You could also write it like that. But again, that it's still not a polynomial because you can't have division. Remember, we don't have division. It's addition, subtraction, or multiplication. Okay.